Okay, so again, this is the chapter test. We use this as a review for chapter 5. And we just started talking about chapter 1. The scale factor can be written in one of two ways. Okay, this is the scale statement right here, 1 to 128. So the top one is the model measurement, and the bottom one is the actual object measurement. So a 1 to 128, always the model values are first. So the scale factor would be, really it's a number expressed as a fraction. Okay, you could also do this though. If you said the scale factor was 1 to 128, I've also accepted that as well. So either one of these are okay. Usually the scale factor though is written as a number, a fraction, a number over another number. Okay? Yes?
So that ratio is not like?
Either one is okay. This is, the scale factor is technically just this number right here. Now, if it was, so obviously this is a reduction because the model is very much smaller than the actual, right? So it's a small model. If you had a big model, like of an atom or something, and you had this big model of an atom, then the top number would be really large, and the bottom number would be really small. Okay? But this is the scale factor right here. Okay. So B says, if the airplane model has a wingspan of 30, what is the wingspan of the actual plane? Okay, the model is 30. Remember, model is 1, actual is 128. So if the model is 30, we can calculate what the actual part on the plane is, right? In a simple proportion like this. And so what ends up happening, remember with this, you can go, x can go across the equal sign from the bottom to the top, and the numbers can also go across the equal sign from the bottom to the top, and they can go from top back to bottom across the equal sign and all that stuff. So here we have x equals 30 times 128, which makes sense, right? If you have the model is 30 and you have a scale of 1 to 128, then it's just multiply by 128 to get the actual real measurement, right? Just multiply. Okay, so 30 times 128. Now I do have the actual answers over here on the side. So here's the actual answer and some work for 1A and 1B. Okay, so I'll let you take a look at that as well, 1A and 1B. So you just multiply through and you get 3,840 centimeters. 3840, and you will need your units there. Or you can move the decimal place back twice and you can write it as 38.40 meters. So either one of these two would be fine for B. Okay? Any questions? Okay, so number 2 says the distance between two cities on a map, so we're having a map in front of us and it's actually about 7 centimeters. So that's the model, right? That's the model. The actual distance between the two cities is 350 kilometers. What is the scale used on this map? Write your answer in the most simplified form. Okay, and I don't know if anybody got this one correct. So we've got 7 centimeters is to 350 kilometers. The problem is we want to get these to the same unit if we're going to talk about a scale, right? So a scale means they both have to be in the same unit. So what you can do is you could change this kilometers. It's easy to change that to meters. Do you remember the relationship between meters and kilometers? Yes, times that sucker by 1,000. Okay? So watch what happens here. This is 350,000 meters. Are we in the same units yet, guys? No. So do we have to do another conversion? We have to get meters to what? Centimeters. Okay? So how do I get meters to centimeters? Times by 100. Excellent. So this is 350,000, and then 2 more zeros. So that's actually 35 million. Now, the simplest form, so right now they're in the same units now. So I've just, really, this is a scale of 7 to 35 million. In simplest form, let's try and divide both of these by 7. Think we can do that? That's going to be 1 to what? Yeah, 35 divided by 7 is going to be 5. So is that 5 million?
Yeah.
1 to 5 million. Okay. So here's the answer for question number 2. I'll bring that in. And it is 1 to 5 million, you can see down there. So that's our answer. Okay, anybody have any questions right now? About 1 or 2? No? We're good? Yeah? Okay. Okay, so number 3 here. Number 3, in a photograph, a man is 1.3 centimeters tall. So here's the picture. You don't have to draw, a picture here, but it might be nice to visualize, and you can certainly feel free to do that. 1.3 centimeters tall. 1.3. And a flagpole is 4.8 centimeters tall. So here's the flag. Little Canadian flag there. This is 4.8 centimeters. That makes sense? If the man is 190 centimeters tall in real life, how tall is the flagpole to the nearest centimeter? Well, you know what? We have a proportion here now. This man is actually 190, right? And we don't know how tall the flagpole is. So you could make a ratio. You could go, model to actual. That's usually what we do. So you 1.3 centimeters to 190 centimeters. And that's going to be the same ratio as the flagpole to its actual height. So remember the model on top and the actual on the bottom. Okay? So take a minute to confirm, solve for x here. Or if you got it right, then just help someone near you if you need to. But I want you to solve for x, make sure you can do it. Alright, so solving for x, you can get x all by itself here. Remember that x can go up across the equal sign up there, the 1.3 can come down here, the 190 can go up there, and so this is what you end up with, and your answer to the nearest centimeter is 702. Alright, so number 4, okay, so I'll leave the answers over here on the side so you can kind of see, because some of these are pretty straightforward, but Charlotte is building a dollhouse that is a scale replica of her own house. One of the windows on the front of the house is 105 wide and 126 high. So that's the actual window, the actual. And a lot of you guys got this mixed up and you used this as like the model and this is the actual or something. So you got to read carefully, okay? On the dollhouse, the window is 7 centimeters wide. So guess what? These are the two measurements that are connected. Here's the model and here's the actual. So we've got 7 over 105, right? The scale statement can be written as 7 centimeters to 105 centimeters, okay? So that's 7 to 105 or 1 to 15 when you divide both sides by 7 to get it in simplest form, okay? So that is your scale statement. And a lot of you, for this particular assignment here, didn't know the difference between scale factor and scale statement. Okay? So the scale factor technically is a number. I'm going to let you write the scale factor like this if you want, but the scale statement has to be written like this. So scale factor, again, it's 1 to 15. It should be a number where the model measurement is on top. So that's the scale factor right there. Easy, right? Okay. Now, C, what's the height of the window in the house? Okay, so you could do this a couple different ways. So right now, we could say, hey, there's the width, right? Width, and here's the height. So I could set this up as a proportion. I could do 7 over 105, because that's, model to actual of the width, and then x to 126. X to 126. And I think that would be a great way to do it. That's kind of the way I've been teaching you, writing this as an equation, right? So 7 times 126, that could be moved up there. So this is what x actually looks like. And then x is going to equal 8.4 centimeters, because that's the unit that we're talking about. So what is the height of the window on the dollhouse? That's what we're solving for. X, window on the dollhouse. 8.4 centimeters. Okay? So don't write 1 to 8.4. Don't write just 8.4. It has to be 8.4 centimeters. Okay? All right. Number 5. Okay, so number 5, I think most of you did great on this one. So I was really happy. Here are the views for number 5. I'm not going to go over this too much. But like I say, make sure that you read carefully. Okay? Front, top, and side. There's 3 views we're looking for here. If you drew both sides facing different ways, that's great. You only need to draw one. So remember, these are the top pieces, the faces that you would see from the top. And if you want to color them in like I'm doing, that's great. So the top has 1, 2, 3, 4 in a row. Then it has 1, 2, 3 along the bottom. And then it has this 1 right here. So that's this one right there. So that's the top view, the side, and the front. Okay? So that's the process. You could shade in what you need to and then sketch it. Okay? But I think all of you did really well on this one. Okay. Perspective drawing. Okay, we still need to work on our perspective drawings a little bit here. Again, what's happening is you're only getting part of it. Okay? So this is the perspective drawing. Something like this, it can be a little bit deeper, and some of you drew the lines on the inside. That's totally fine. This is all that's necessary right here. So let me just move this out of the way. And again, you're going to want to use a ruler. Okay? Ruler. Please use a ruler. And what you want to do is, with a pencil, lightly if you want, but put your ruler down and connect these 2 lines. And draw a nice straight line between this corner and this line. Then go to this corner, to this line, to this point, sorry. This corner to the point, and again, you're going to use a ruler. It's going to be much nicer than mine. So for the most part, all of you started doing this. But I think where we got off was you guys didn't use all the corners in the diagram, and so it was a little tough for you. Now the back side doesn't matter so much, but you're going to want to at least draw the lines towards that. So now what you do, the second part, right, is you kind of mirror the edges. So this is the top edge that should be parallel with this one. From here down to this one should be same as this. From here, parallel to this edge, and then parallel to this edge. Okay? So mine might look a little bit funny because I haven't used a straight line ruler. But then what you're going to want to do is you're going to want to get rid of all this the back part. So this is what you're left with. Right? Sorry. Okay? That sort of thing. Something looks wrong there. I'm sorry. So all these lines here, there, this one, to there, this one. May as well do all of the little step lines there. Okay? Maybe that's why mine looked a little bad. I guess I forgot a line. Okay? So anyway, so once you have your ruler, once you connect all of your corners, okay, then your perspective drawing should look something like this right here. Okay? And it doesn't matter how deep you make it look. Just pick all the corners. Do all the corners. And just make sure you've done all of them. I just kind of skipped a few there. Okay? So that's perspective drawing. Any questions about that? If you drew like these pieces or whatever and had like little lines, that doesn't matter to me. You don't need these though. I don't know if that would be a very wise thing to do. So I wouldn't draw those ones. Okay? All right, so let's keep moving on here then. Okay, this is the one that I really want to focus on, okay? So this was presented just a little bit differently than most of the questions that you've had, okay? But what this does, this kind of question combines 2 different things that you're supposed to know about. That is front view and side view and isometric diagrams. So the reason why this doesn't look exactly like a question you might have had is because it's combining it on a test, right? You can't ask 50 questions, all testing a different thing. Sometimes we have to ask questions that test a few different things at once. Okay? So none of you got this right, I don't think. Every one of you struggled with this. So let's take a look at it. So the height of the chair, so this is the front view of the chair, this is the side view. You are definitely not, okay, this is what you're not doing. You're not drawing like a side view of the chair like this, okay? And many of you did this. It's like, okay, that is not right at all. What you got to do is you got to draw the three-dimensional, right? So you have to pick a scale, okay? It says here, doesn't it say, yeah, I should draw, okay. So we have to pick a scale. We have to like state some kind of scale. So these dots have normally been 0.5 centimeters. That's what they are, right? So if this is 90 centimeters, right? If we did 1 to 10, if we did 1 to 10, then our diagram should be 9 centimeters if this is actually 90 in height, right? So can we do 18 centimeters for the height? Yeah, we can fit that on the paper. Now here's where they want you to start with this black edge. That's the front edge, okay? So they're just saying this is the perspective that they're looking for. So this is 35 centimeters plus 10 is 45. So 45 centimeters is actual. So this has got to be 4.5 centimeters. Does that make sense, guys? So how many dots is 4.5 centimeters going to be? How many dots is that? 9. Yeah, times 2, right? So I think all of you need to either redo this, or did you guys do this last period, some of you, or this morning? Yes? Where's yours?
Yeah.
Let's see.
Oh, no, I did it.
This is all right, so this is very important. So we're going to go up, what did we say? I forgot now. 9 squares, right? Because we need 4.5 centimeters for this part right here. That's 35 and 10 is 45. Good. Let's go up 9 dots. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So that's going to be our front edge right here. Okay. All right. So what I want to know here now is how far do I go, like from here to here? How far is that going to be? This is the seating area, right? That's going to be what? From here to here is how many centimeters in real life? 30 plus 10 is 40. So that's going to be 4 centimeters. That's going to be 8 squares. So, or 8 dots. So again, go on the angle. Okay, don't go sideways or down. We want to go on the angle. So go 1, 2, 3, 4, 5, 6, 7, 8. So 9 up and 8 back. We good so far? Okay. So if this is 90 in total, guys, what's this distance from here to here? What's that one? And the key is looking at this. Right? This is 45, isn't it? So what's this? 45 plus what gives you 90? 45. So we got to go up 9 squares, and I hope that I have it. Do I have it? I don't know if I do. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, just enough. Barely guessed that one right. Okay, and so again, with your as straight as you can. You don't have to use a ruler. A ruler would be a good idea. So this is the front leg, this is the seating area, the red is the seating area, and the blue is the back again. Okay? So this is 40 centimeters. Yeah, I'm going to run out of room a little bit here, aren't I? So this is 40 centimeters wide. So how many dots do I have to go? Well, 40 centimeters is going to be 4 centimeters, so I have to go 8 dots actually. Right? So this is going to be a little bit, I might be a little bit out on this one, so I'm going to move mine down. You guys can't do this if you mess up, I realize, but you might have to erase if you're going way off. So let's see if I can go, how many is it? 8? 1, 2, 3, 4, 5, 6. And if you go off the paper, 7, 8, that's okay. I'm okay with that. It's looking like we could have used a bit of a different scale. actually, right?
120.
Well, 1 to 20, yeah, 1 to 20 might have been okay. Yeah, 1 to 20 might have been okay. This is looking a little bit big, but we're going to be all right.
I have a question about
Yeah.
that scale. So if we do something like 110 or 120,
Okay, so let's keep it going here. Now we have a lot of parallel lines we can work with, right? So this one was 9 dots, so let's go down 9 dots. Okay, and we can start connecting these now. This is going to be 8 dots. This one, 1, 2, 3, 4, 5, 6, 8. Okay. Okay, connecting there. All right. So this chair does have a thickness. So it's 10 centimeters thick. So 10 centimeters over here, that's actually 1 centimeter, which is 2 dots thick. You see that? So you might want to just add 2 dots of thickness here. And again, if you go a little off the paper, that's okay. Okay, so we're going to add a little bit of thickness there. Okay, so yeah, so this is basically kind of how you go, and you just kind of you keep rolling here. There's a 10 centimeter. There's a 10 centimeter, so this is the thickness of the chair here, right? There's a thickness of the chair there. And so on. So okay, so you just want to double check that everything is working out. So the leg itself is 35 centimeters. So 35, that's 3.5 centimeters. That's 7 dots, right? So did we do that right? 1, 2, 3, 4, 5, 6, 7. Oops. Where did I go? 1, 2, 3, 4, 5, 6, 7. Sorry, just to there. Okay. And 2 centimeters, so everything is 1, 2 thick, and so on. One, 2. Okay. So, do you guys have any questions? See how this is shaping up here? This is how you do this one. Okay, so it's going to take a little bit of time. Yes, it's going to take a little bit of time, but use your dots. Line everything up. Okay. And see how that's getting filled in there now? Okay. And that's that looks like a pretty good drawing right there. So these dots here look a little funny. So this is 1, 2, 3, 4, 5, 6, 7. Yeah. Okay. Okay. So here's the actual. There's the drawing right there. You don't have to draw the dotted lines, the ones that you can't see. I'm not too worried about those. So if it looks something like that, that's perfect. If it's a little bit smaller, if the scale is 1 to 15, okay, that would be fine as well. You're just going to have to go kind of halfway in between 2 dots, maybe. Okay? Questions? So if you're having trouble drawing this, here's a little tip. Please do this. Make sure that lines are parallel with each other, okay? So parallel means that they don't go kind of cockeyed like this at all, ever. They're always straight up and down, or they're kind of this way along the dots. So you see how all of these vertical lines, see there's a bunch of vertical lines that are parallel. And then these ones are always along the dotted lines. They're also parallel. This one and this one, okay? So little like diamonds, okay? And things like that. All right. Okay, let's move on to the next one. Spend enough time on that question. Okay. Okay, so we're getting close to the end here, guys. Just want to pay attention. So this one here as well. Again, the what is this one asking for? It's asking for component parts, okay? So really we have the top piece and we have 4 legs. That's it. The top piece and 4 legs. The depth, okay? You don't have to put the depth in. You can. I would welcome that. But really, I mean, you got to draw a triangle, okay? And it does say an appropriate scale. So that means that when you draw with your ruler, it has to measure out to the same, it has to be the exact same shape as the actual drawing. So you see how this is 25 to 45, okay? So if you use a scale of 1 to 10, which is usually good, then it's going to be 4.5 centimeters and 2.5. It's going to be 0.7 and 2.7. Those are going to be the actual measurements. Okay? So if you want to do the depth as well, you can. I don't mind. So just draw this as well to scale, if you can do it. Whatever that's, oh boy, that's a bad line. But you can draw the depth as well, and then make sure that you do times 4 for the legs and times 1 for the tabletop. Yeah.
So when I was doing 25 divided by 110, and that give me 7.
25 divided by 110? Divided by 10, you mean?
All.
So this is, sorry, I don't know if you can see this. This is 1, 2, 10. So that means that 1 centimeter would be 10 centimeters in real life. Or 2.5 centimeters would be 25 centimeters in real life. Okay? Okay. Okay. So scale statement. Make sure you put a scale statement. It says that. So guys, please read the question carefully. Underline and circle the important parts. I would strongly encourage that. So you know you have a component parts diagram. Okay, you won't forget that if you underline it. Appropriate scale. Right, I got to choose a scale. Label the parts with their dimensions, okay, and provide a scale statement as well. So that's how you know, that helps you not forget anything. Any questions on component parts? There's no 3D in there. The last one though, the last one we need to take a look at, draw an exploded diagram. Okay. The exploded diagram is the 3-dimensional picture. Okay, you can't do, this is not an exploded diagram, which some of you tried. You can't do this. Okay, this is not good enough, and you can't just kind of go like this or whatever. Not quite good enough. Okay, and I know some of you aren't great 3D drawers, and I understand that, but remember, think about parallel lines, opposite sides are parallel, and then that should begin to help. So what you want to do is you want to separate, and this is actually a pretty easy one, guys. You want to separate the top from the legs. You basically want to draw these legs shifted downward, okay, with enough space that you can see the whole leg, and also so that they're lined up with the proper parts of the table. So this is how I would suggest going about this, okay? So you draw the tabletop, and again, you would use a ruler. I can't really use a ruler on this tablet. You draw the tabletop, preferably to scale, okay? And draw the thickness, and so each of these little lines have to be straight up and down. Each of these side lines need to be parallel with the edge that they're on. And then here we go. So watch this. So the legs have to be kind of pulled apart. And they have to, again, this line would be parallel with this one. This line parallel with this one. And you draw the little legs, little diamonds on top with the legs, like this. Okay? Straight up and down. On the angle, on the angle. Then you do that for each leg. Okay? And then you draw the dots. Now, not many of you drew the dots. Some of you drew like you dotted one part to one part, but that was it. Okay, so this is what I'm looking for. I'll answer your question in a second. This is what I'm looking for. This corner goes to this corner. This corner goes to about there. That corner goes to about there. What would be under the underside, right? So something like this, right? Actually, that would be down here. So dotted lines. If you don't draw the dotted lines underneath the table that's shown, that's fine too. I'm okay with this, right? Something like that. And then you would do that for all 4 legs. Okay, so you'd have 4 legs that look exactly the same. And I'm just going to cheat a little bit for time's sake here. Okay, so this one, ooh. Oh boy, okay. Okay, I don't think I can move those now. That's too bad. Okay, guys. So you would draw all four legs, and they would kind of go right where they're supposed to go, kind of like that. You see? And this one here, same thing. Underneath there, line them up, and so on. So draw them so you can see them all. And this one you'd have to kind of show that it goes to the other side here, right? And so on. So somehow, right, show that they go to their appropriate spots, okay? Now, did you have a question?
No.
Okay. Any questions about that, guys?